Alright guys, welcome to this page of the notes, and again what we're going to do is there's actually a lot of sort of real life application that actually has radicals in it, and we're going to go ahead and take a look at it, a couple of examples of those on the next couple of pages of the notes. The one that we're going to look at here actually has to do with how far you can see out of the periscope of a submarine depending on the height of the periscope above the water. Let's go ahead and take a look at this. A lookout on a submarine is h feet above the surface of the water. The greatest distance, d, in miles the lookout can see on a clear day is given by the square root of the quantity h, which again h is the feet of the periscope above the surface of the water, multiplied by 3/2. Now you're going to need to write your own function here, but I've essentially given you the function in word format. We are going to be looking for the distance that you can see in miles on a clear day, right? How far, depending on the height of the periscope, how far can you see on a clear day? And I tell you how to figure that out. The distance that you can see on a clear day is given by the square root of the quantity h multiplied by 3/2. So we have 3/2 times the square root of h. And again, remember, h is the height of the periscope above the surface of the water, and d is how far you can see. Now, obviously, this makes sense. The higher the periscope above the surface of the water, the farther you're going to be able to see. So the equation makes a lot of sense. And here we go. We need to go ahead and graph this guy as well as state the domain and range. I've asked you for the domain and range of this function. So let's set up our XY table. And here we go. We're going to go ahead and pick our perfect squares because we want to work smarter, not harder. And if I choose my first perfect square, which is 0, well, I plug a 0 in for h. So you are 0 feet above the surface of the water. You haven't risen your periscope at all. How far do you think you're going to be able to see? Yeah, 0 miles. It should make perfect sense. The square root of 0 is 0. 0 times 3/2 is 0. You can't see anything, right? You haven't raised your periscope anywhere, so you're not going to be able to see anything. Let's go to my next perfect square, which is a 1. Oh, I'm sorry. Hold up. I've got these guys all screwed up. I put x's and y's. It's actually h's and d's. This is going to be h. This is going to be d, where h is the height of the periscope above the water, actually in feet, and then d is the distance you can see in miles. All right, so I apologize for that. It should be h's and d's. H is on the x-axis, d is on the y-axis. I shouldn't even call them that. H is on the independent axis, d is on the dependent axis. How far you can see is dependent on how high the periscope is above the surface of the water. Whew. Now that we got that all cleared up, I apologize if I confused you. Let's keep going. Height of 1 foot. Well, I plug in 1. The square root of 1 is 1, and 1 times 3/2 is 3/2. Sure, it's a decimal, but it's not that difficult, and it's a word problem. Highly unlikely you're going to get nice, neat numbers anyway. We'll deal with it. My next perfect square is a 4, so I'm going to plug in a 4. Square root of 4 is 2. 2 times 3/2. Well, the 2's are going to cancel, and you're left with 3. All right. Next perfect square is a 9, so I'll plug in a 9. 9 times. The square root of 9 is 3, and 3 times 3/2 is 9/2, which is 4.5. All right, let's go ahead and graph these guys and see what our function looks like. My first point is at 0, 0. My next one is at 1. 3/2 is 1.5, so we'll be at 1, 1.5. My next one is at 4, 3. And the one after that is at 9, 9/2. 9, 9/2, but 9/2 is 4.5. So 9, right about there. Connect those dots with a nice smooth curve. There you go. You've got the graph representing the function, which gives you the distance you can see on a clear day in miles per how high your periscope is above the surface of the water in feet. Looks like a nice square root function there. I asked you for the domain and range. Let's go ahead and hammer that out real quick. Domain and range, not too difficult. Obviously, right, the domain is anything greater than or equal to 0. So x is greater than or equal to 0. The range is also y values greater than or equal to 0. All right, so there's my domain and range. Makes perfect sense. Obviously, you're not going to be able to raise the periscope 0 feet above the surface of the water, right? That would be diving, and you're not going to be able to see anywhere. If the submarine is so far underwater, the periscope won't reach the surface. And of course, that means if you're underwater, you're not going to be able to, you can't see negative distances. So that's why we started 0, 0, and everything should make sense. Everything heads in the positive direction. So those should make perfect sense. And let's move on to the next part of this problem, which is where I then ask you to go a little bit further. So let me slide right to here. All right, here we go. I want a ship is 3 miles away from the submarine, and I want to know how high would the periscope need to be raised in order to see the ship. Well, remember, my equation is d equals 3/2 square root of h. H is the height of the periscope above the surface of the water. D is how far you can see in miles. Well, I tell you there's a ship 3 miles away. How high does the periscope need to be in order to see 3 miles out? Well, that's really easy to do. Plug a 3 in for D and solve. Let me slide down a little bit so you can see my work. And here we go. The first thing I'm going to do is multiply 2 to the other side, which means I have 6 is equal to 3 square roots of h. Divide by 3. 6 divided by 3 is 2 is equal to the square root of h. I need to get h by itself in order to undo a square root. We know the inverse function is square. So I'm going to square both sides, which means that h is equal to a 2 squared, which is 4. So I know I'll need to raise that periscope at least 4 feet above the surface of the water in order to see a ship that is 3 miles away. However, if you were paying attention, you would have quickly recognized we actually had already done that one in our chart. A height of 4 feet above the water shows me a distance of 3 miles away. So if you've been paying attention, you already know h needed to be 4 feet because it was in our chart. Guys, that takes care of this word problem. Head on over to the next page of the notes and we'll take a look at another one. I'll meet you over there.